going to do a quick recording of what would have been in class today had I been there. Sorry about that. And if you watched the Tuesday video, you already saw a little bit of u-substitution. Hopefully this will clear up some questions that you had concerning that video. But let's start with the chain rule, and then we'll get into the reverse chain rule, which is u-substitution. You can also work backwards recognizing patterns, and I call that pattern recognition, but you don't have to. So this is a method that is logical, follows an order that will always work in solving your backwards chain rule problems. So first let's find the derivative when y is equal to x squared plus 1 raised to the third power. One question you might have would be from a long time ago, why is it d dx? Similar to the question that people are asking, what is dx or what is dy, which we were cheating and then separating them, and that's fine. Even Khan said that we were pretending to cross multiply when really you shouldn't, because it is one thing. It is slope. It's one thing that represents slope. But even this notation, which is Leibniz notation, in separating out the ddx is a little bit of cheating. Okay, so I had said a long time ago that ddx is a command, find the derivative. So if I take this y and plug it in right here where you see y, right there, instead having the x squared plus 1 cubed going in there, then it's d of the y right here, dx, and then I can isolate out this d dx. So I'm kind of, chunking my derivative here. And we did a lot of these. We had a timed quiz on that, a lot of derivatives. We did chain rule. And just like the power rule, you decrease the power by 1 after you pull out the coefficient. So 3 comes down in front, and then you decrease the power. So it's 3 quantity x squared plus 1 squared, and then times 2x. That's the chain rule part. I did mention that you should know the models. There were about 7 different models that you should know, and one of them was the power model, and then there was trig, there was E, there was ln, and there were arctan, arcsine. We'll get into that. But I wanted you to start identifying the inside piece, the u on the inside. And in this case, that is x squared plus 1, so inside pieces. Remember, chain rule is how we handle compositions, and we spend some time looking at compositions, f of g of x, and then we change that to f of u. So we were constantly finding the derivative that had an inside piece. So anyway, here's your derivative. In blue, sorry about that. But if we can find the derivative here in blue, then we should be able to work backwards. So then we're thinking the integral of that derivative should equal x squared plus 1 cubed plus c. But how? Some of you have already started to see this, and that is you using, pattern recognition. So you are adding 1 to the power, maybe you're doing that, and then dividing by that number, which is a 3, and that gets rid of the 3. You've made your peace with the fact that this chunk is going to disappear, and you're going to get back the x squared plus 1 cubed. It's almost like this goes back inside the piece. It somehow gets absorbed inside, and that's fine. There's a lot of you, though, that are not fine with this, and you can't see that pattern. So here's the plan. U equals the insides, okay? And then you take a derivative of those insides. So the inside is x squared plus 1. Take a derivative of that. These are connected, and write down du dx is equal to 2x. Then, in the video, they did cross multiply. Okay, they did cross multiply. Du is equal to 2x dx, and they even took it one step further and solved for dx. Dx in this case is equal to du over, 2x. Yeah. So you can do that. We don't need to do that here, because what we end up seeing is a perfect match. A perfect match of 2x dx is right there. And so you're going to substitute everything. You're going to replace everything. Here is that blue piece. That 2x dx became du. And then we'll do maybe a red piece for this piece here. That became u squared. And it's a much shorter problem now. The 3 is still there. Okay, eventually the 3 will go away, but not yet. But this is the kind of problem that we were working on yesterday, just a basic power rule. So we're going to integrate using our new reverse power rule, and that's how the 3 goes away. We are going to add 1 and divide, add 1 and divide, add 1 and divide by whatever that number is, and that'll end up giving you your answer, which is u cubed plus c, and now all you have to do is put all the x's back. Okay, so this way, if you follow this method, you will get the antiderivatives without, I guess, the intuition. And you might not be ready for the intuition, and that is fine. Okay, but the video did have that dx piece, and I want to talk about that. So let's do another example. This one's a trig model, and with the trig model, u is on the inside, so in this case, u is 5x. You might already be able to guess whose derivative this is because it comes from sine, but you know that it's not exactly sine of 5x, and that's fine. So you could guess and check and adjust it. That would be okay. Or you can do u-sub. And this is the process that will guarantee you get the answer if you follow it correctly. Okay, so first off, let u equal 5x. And then if you want to skip over, the du dx part, that's fine because you know you're going to cross multiply, even though it's kind of cheating or pretending, as Khan said. That's fine, but this is always going to happen. So you're going to have a u, and you're going to have the subsequent du, dx that goes with it, and then you're going to substitute in. Now, the video did take it that step further, and they did isolate in pink here that dx. So they just divided both sides by 5 is what's going on. Okay, so you can do that, and then this chunk goes in for dx. Okay, and that would be great because that's how you can get that 5 on the bottom. Some of you have already adjusted and you saw that there was a 1/5. That's fine too. But here's something that might not have been explained on the other video. I think it was the organic chemistry tutor. I think that's the video I gave you. Anyway, coefficients can be pulled out. So one thing that might have happened on the video was that a number was pulled outside of the big S, and you're allowed to do that. You're not allowed to do variables. Okay, so you can't pull out an x. I mean, otherwise the whole problem, you could pull everything out, and then what's the point? So you can't do variables, but you can pull stuff that is inside here as long as it's a coefficient. Okay, even the number like 3, if there was a 3 in there, you could pull it out because it's the coefficient of dx. It's not actually a term like plus 3. So be careful. We're just looking for multiples. Like here, I could pull out a 2. For example, these are the same. You're allowed to do that, okay? You're not allowed to pull out variables. You can't pull out functions, different things like that. But let's work this one to its natural conclusion here, okay? Whose derivative is cosine of u? That's going to be sine u. If you pull out the 1/5, you get to see the question. This is asking the question, whose derivative is cosine u? You say sine u, and then the coefficient just hangs out. You don't have to do anything with it. It ends up being just a multiple, and that's fine. And then, of course, make sure you put your u, you replace your u with your x's, put your x's back. But that's the final answer. So we will talk again. Tomorrow is just a Wednesday video. It's not going to be class time, and I think I'm going to post an optional, the 20-minute math lab check-in if you want.